Okay, this is chapter 5.5 and 5.6 for math, algebra, pure math, whatever. Question 1 for 5.5. The table gives the values of a function f for certain values of x using the trapezium rule with 6 intervals of equal width to estimate 1 to 4 f of x dx to 2 decimal places. So what's the trapezium rule? It's h over 2 f of x0 plus 2 of f of x1 plus 2 of f of x2 plus dot 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 f of x n minus 1, 2 f of x n minus 1, and then the last one is just f of x n. So it's always 2 times except for the first and last. And this h is equal to, what did we say it was equal to? For any integral a to b, it's b minus a over n being the amount of subintervals. In this case it's 6, so b minus a over n, so 4 minus 1 over 6, so it's gonna be 1 over 2. In decimal form it's 0.5, so we can just plug this all in. Here they should have 7 values, 1 2 3 4 5 6 7. Why 7? Because the amount of values you use always is 1 more than the amount of intervals you use, because an interval has 2 numbers. An interval is any value in between 2 numbers. So since it's 2 numbers for one interval, it's actually 7 values. You can think of that later, but anyway, if you have 6 intervals, you're gonna need 7 numbers. Okay. Anyways, so we're gonna start like this: f of x0, because you start counting from 0. Well, that's why there's 7 numbers. So let's start. H, we said 0.5 over 2. F of x0, you just plug these in: 0.84 plus 2 f of x1, 0.95, so 2 times 0.95 plus 2 times 1.28 plus 2 times 1.96 plus 2 times 2.30 plus 2 times 3.0 plus 2, not 2, plus 3.82. Why not 2? Because it's the last value, and the last value isn't multiplied by 2. So we can do this on our calculator. Let's do 0.5. I'm just gonna cut to where I put it on a calculator, okay? As you can see here, it's 5.91. You can read over this if you want, but I just plugged in all the variables. Question 2. Integral minus 6 to minus 3 dx is estimated using the trapezoidal rule with n equals 3. The estimate is k over 3, where k is a whole number. What is the value of k? So they want us to just use the trapezoid rule for this integral. What is the trapezoid rule? H over 2 a1 f of x0 plus 2 of f of x1, and it keeps on going until you reach 2 f of x n minus 1, and then f of x n, right? Let's find h first. It's b minus a over 2, so minus 3 minus 6 over n, right? It's b minus a over n. Did I say b minus a over 2? Maybe I did by accident. So it's b minus a over n. That's h. If you don't know, just watch question 1. I explained it a bit more. So n is 3, so over 3. So you're going to get minus 9 over 3. So it's equal to negative 3. So h is equal to negative 3. So let's start plugging in our values. Negative 3 over 2. But here they didn't give us the table, so we actually need to find f of x0, f of x1, whatever. We have 3 sub-intervals. So how many values should we have? 4. Okay? So we start first with b, as the b, a to b. You start first with a, or whatever you want to call the bottom number. And you want to work your way up until where? Till minus 3. But how much are we adding each time? The amount you're adding each time is the value of what you got over here. Wait, I just realized I made a mistake right now. So this is all fine, except here, let me just repeat it. When I found h, it's b minus a over n, right? So b minus 3 minus a. A is negative 6, so I forgot about double minus. I just put minus. Okay, over 3, and you should get 3 over 3, which is 1. So h over 2 is going to be 1 over 2. Anyway, so we know h is equal to 1. We'll substitute later. But why I figured this out is wrong, because when you're substituting to get your f of x0, f of x1, f of xn minus 1, whatever, and so whatever, every time you're adding by your h value. So you start at minus 6, you want to work your way up to minus 3, and you have to use 3 subintervals. So you're gonna work your way up 3 times. okay? And every time you work your way up once, you add by h. So why I got confused, because I got h is equal to -3. If you add -6, -3, oh, you're gonna get -9. I was like, wait, that's definitely wrong, okay? So it's actually a way you can check your answer in your exam. Anyway, over here, we're gonna work our way up from -6 to -3 three times. So we're gonna start at -6. We're gonna add 1 each time until we reach -3. So -5, -4, -3. As you can see, that's 4 values, as we expected, right? As we expected 4 values, because if n equals 3, the amount of values I have is always 1 more than n. So anyway, let me chop. We're gonna substitute these numbers one by one into our function to find how much the function is at that value. What is our function? Our function is 10 over 1 plus x, right? So 10 over 1 plus x. Let's substitute -6, so it's going to be 10 over 1 minus 6, which is -2. Let's put x, f of x. Okay, -5 will be 10 over 1 minus 5, which is -2.5. -4 will be 10 over 1 minus 4, which is, and then negative 10 over 3 is, hold up. Yeah, it's the simplest form, so -10 over 3. So I'm going to keep it as a fraction because it's a repeating decimal. Then -3, 10 over 1 minus 3, which is -5. Okay, so over here, -5. So we now have our values, and we can plug them in, right? So over here, let's start. H over 2 is 1 over 2. F of x 0, so -2. Plus 2 times f of x 1, so 2 times -2.5. Plus 2 times -10 over 3. Plus 2, no, not plus 2 now. Plus -5. Why not times 2? Because khas is the last value. So put it in our calculator. Again, I'll cut to when I put this on my calculator. As you can see here, it's -28 over 3. So it's equals -28 over 3. They're asking for k, so it's going to be -28. In simple terms, what do you have to do when you see a trapezoidal question like this? The first thing you do is write down your formula. Okay? If you don't write down your formula, that's completely fine. But you need to get to this table. When you get this table, everything is easy. To find this table, you need to know which values are you going to be substituting. To do that, all you need to do is find h. Okay, b minus a over n. It's 1. And you keep on adding 1 until you reach your top term. How many values? That doesn't really matter. But all you should know is you start from the bottom one to reach the top one. You keep on adding this h value. Okay? When you reach it, khalas, you know that -6. I work my way up until -3. That means every time I add 1, these are all the values I should substitute. Okay? You get these values, substitute them in, and then apply your formula. It's not that hard. I went a bit in detail. Okay? Let me continue. Question 3. Use the trapezoid rule with n equals 4 to find an approximate value for this. So let's go a bit quicker. We first need to find our h. It's b minus a over 2 over n, right? So 2 minus 0 over 4, which is 1 over 2, which is 0.5. طيب. Let's work our way up from 0 to 2. So we start at 0, we add 0.5, 0.5, we add 0.5 again, 1, we add 0.5 again, 1.5, we add 0.5 again, 2. So I know that these are my values that I'm going to be substituting, right? Type. What are we substituting it to? 1 over 1 plus x squared. People are going to say, where do you get the 1 over from? 1 plus x squared is in the denominator. Is there any numerator you see? No. So that means you just put a 1. It's a hidden 1. You don't write the 1 on top. If there's only 1, you don't write it on top. Anyways, let's start substituting. 0, 1 over 1 is just 1. Then for 0.5, it's going to be 1 over 1 plus 0.5 squared. This is going to take time. So let me just put no, don't do this in the exam. If I show you this, you can do this in the exam. Don't do it because it doesn't always work in every question. 1 plus 0.5 squared. Do what I'm doing now, but I was going to do something else that doesn't always work. Don't just ignore what I was doing. Anyways, 1 over, let me do this a bit faster. So I want to substitute all the values one by one so you can see I'm not going to cut. 0.5, then 1.5 over here. 4 over 13. See, if I put it, it won't give me 4 over 13. It would give me the decimal. I don't want that. Okay, and then 2. 0.2. Okay, now can we apply the formula? Yes. We always start with h over 2. What's h? 0.5. So 0.5 over 2. Start with the first term, 1, plus 2 times the second term, plus 2 times the third term, plus 2 times the fourth term, plus the last term without multiplying by 2 because it's the last term. Now you can put this on your calculator. I'm gonna cut to when I... Oh, stop. While I erase it. Stop. Ya Allah. Okay, so I rewrote most of the stuff. I'm gonna put this on a calculator and cut to when I write, okay? As you can see here, you get 287 over 260. So the answer for the value for k is 287. Question 4. How long is this recording? Oh my god. Okay, they gave you the table. Again, trapezoid rule. Enter your answer as decimal number. The only thing you need to do is h over 2 and then the formula, alright? I'm not gonna write it all. So we have everything here, but what we need to know is what is the value of h. The value of h is just b minus a over n. So 2 minus 1 over n. How many subintervals do we have? Okay, 1, 2, 3, 4, 5, 6. Is that the amount of subinterval? No. You do 6 minus 1 equals 5. Why? Because this counts as one subinterval, this counts as one subinterval, this counts as another, this counts as another, and this counts as another. And that's 1, 2, 3, 4, 5. Okay? So you can think of it as that. Okay? That's what the subinterval is. It's all numbers in between these two. If you want to not waste your time, just count how many values you have and we'll subtract by 1. Okay? So 2 minus 1 over n is 5. So 1 over 5. So it equals 0.2. So h is 0.2. So you do 0.2 over 2. 2 times, and as I 0.7, because it's the first number, you don't multiply by 2. You only you multiply by 2 for everything except the first and last value, right? So 0.7 plus 2 times 0.6 plus 2 times 0.5 plus 2 times 0.4 plus 2 times 0.3 plus 0.2. Okay, and I'm gonna cut to when I do this on my calculator. As you can see over here, you get 9 over 20, which is just 0.45. So we're done, but 5.5, let's go to 5.6. Okay, 5.6, all about improper integrals. Let me get to the point. First question, 4 over x cubed dx from 1 until infinity. Remember, when working with infinity improper integrals, you start by saying 1 until b and integrating normally. Okay, let's integrate. Integral 1 to b, 4x to the minus 3 dx, so it becomes 4x to the minus 2 over minus 2 from 1 until b, so it's going to become negative 2 over x squared from 1 until b. Okay, then you say limit b approaches infinity, okay, of minus 2 over x squared 1 to b equals, then you just replace b with infinity, so minus 2 over, oh no, sorry, you don't do the limit now, my bad, you do the limit after, I forgot one step. Then you substitute b and 1, so you can get minus 2 over b squared minus open bracket minus 2 over 1, right? Then you say limit b approaches infinity. Okay, so you're gonna get of minus 2 over b squared minus 2 over 1 is just minus 2, so just you can change it to plus because minus. Okay, so you're gonna get negative 2 over infinity squared plus 2. Negative 2 over infinity is just 0, so it's gonna be equal to 2. So the integral converges at 2. Okay, so if it was written integral converges to 2. Okay, for the second part, you need to simplify a bit before integrating, right? So it's going to be integral 3 until positive infinity, dx over x minus 2, 4 root x minus 2. Okay, so dx over, I'm going to change these into powers. Okay, since the same thing is under both radicals, then you can simplify it, okay? So it's going to be x minus 2 to the power of half, x minus 2 to the power of 1 over 4. When you multiply two numbers with the same base but different exponents, you just add the exponents. So 1 over 2 plus 1 over 4 is just going to be 3 over 4. Okay, so it's going to be the same as integral 3 to positive infinity dx over x minus 2 to the power of 3 over 4, and now you can integrate. Let's change it to b, so it's going to be integral 3 till b. Take this up, it's going to be x minus 2 to the power of negative 3 over 4 dx. Go down. We're going to integrate it now. Obviously, to integrate this, you need to use u substitution because it's more than one term under the power. So we're going to set u to be x minus 2. So du is equal to 1 dx. Right? Remember, du equals u prime dx. What's the derivative of x minus 2? It's just 1. Okay, so then you just change dx with du because they're just equal to each other. So it's going to be integral 3 to b u to the power of negative 3 over 4 du. So then you're going to get, integrate this, you're going to get u to the power of 1 over 4 over 1 over 4 from 3 until b. Start substituting, take this 1 over 4, you divide by 1 over 4, so 4 goes up, 1 stays down. I'm just doing simple simplification, you can do this all on your calculator. 4 u to the power of 1 over 4 from 3 until b. Fine. Start substituting b, you're going to get 4. This u, we need to change it back into what it would equal to, x minus 2, right? So it's going to be 4 x minus 2 to the power of 1 over 4 from 3 until b. Now substitute, you're going to get 4 b minus 2 to the power of 1 over 4 minus 4 into 3 minus 2 to the power of 1 over 4. Remember, we say limit b approaches infinity of this, so you're going to write of 4b minus 2 power 1 over 4 minus 4 3 minus 2 1 over 4. You can write 2 arrows, substitute now b with infinity. 4 infinity minus 2 to the power of 1 over 4 minus 4 3 minus 2 power of 1 over 4. What do you do here? Infinity minus any number is just infinity. Infinity to the power of any number is still infinity. Infinity times any number is still infinity. So all of this gets you infinity. Then infinity minus this, and infinity minus any number, no matter what it is also infinity. So do you get a number? No. You get, it diverges, so you put 999. Okay, very easy. Question 2. Again, same thing. Dx over root 1 minus x. I'm going to continue doing it. I'm going to do it a bit faster though. Okay, so 0 to 1, you're going to integrate normally. So you're going to say root 1 minus x. So you're going to take root 1 minus x. It's going to become 1 minus x to the power of negative half, right? Integrate it, you're going to get 1 minus, you need to use u substitution, right? Because it's more than one term. So u is equal to 1 minus x. So du is equal to derivative negative x to the power of 1 equals negative 1 dx. So dx is equal to negative du. Okay, right? Because you divide by negative 1 on both sides. We need to rewrite dx. Remember how to use u substitution. So integral 0 to 1, u to the power of negative half, negative du. So to make my life easier, I'm just going to take this negative outside. Okay? Negatives outside. Integrate u to the power of negative half. You're going to get u to the power of half over half. So you're going to get 2, negative 2, negative 2 u to the power of half. Because when you divide by half, it's like taking the 2 up. Okay? In between 0 and 1. Let's fix this. You're going to get negative 2. U, remember we said it's 1 minus x to the power of half in between 0 and 1. Start substituting. Negative 2, 1 minus 1 to the power of half minus negative 2, 1 minus 0 to the power of half. 1 minus 1 is 0. So 0 to the power of half is obviously 0, and 0 times negative 2 is 0. So this gets cancelled to 0. Okay, minus 2, so plus. 1 minus 0 is 1. 1 to the power of half is just 1. And then times 2 is going to be 2. Do this on your calculator, you're going to get 2. Okay, so you're going to get, the answer is 2. Very easy. One thing I'm forgetting to mention, these will all get you the correct answer if you're on computer. But come in, if you're doing unwritten, you also need to use limit for this part, even though there's no infinity. Okay, here you know that 1 minus x cannot be equal to 0, right? So it cannot be actually, like 1 minus x, you know, it has to be greater than 0. You guys know conditions, because it's in the denominator, it's not allowed to be 0, and it's under radical, so it can't be equal to 0. So you take 1 to the other side, you're going to get x has to be less than 1, right? So when you do this, this is your condition, right? You know that x has to be less than 1. Over here, you have to also do the same way we would substitute infinity with b. You do the same thing over here. Let me show you. So when I wrote here 0 to 1, whatever, I should rewrite again another step over here. Change this 1. I'm going to change it to a. Okay, let's call it a. Okay, u to the power of negative half, negative du. Okay, and then I continue solving as a. I continue until the part where I substitute the 1 over here, right? Here I substituted the 1. When I do this, I say limit a approaches 1, and I say plus. Why plus? Because you're going from 0 to 1. So actually, no, 1 minus, not 1 plus. Let me show you why. One second. It's another different lesson. I know it's kind of confusing. When you approach a number, you can approach from the left side, or you can approach from the right side. When you're approaching from the left side, we say you're approaching like this. Okay, negative. When you're approaching from the right side, you're saying 1 plus. Okay, so here, since I'm approaching it from the left side, if you get it in written and computer, you don't have to do all this. Okay, and you just substitute the 1. So you just had to write these 2 extra steps. Okay, I'll solve another question and I'll show you. Okay, so you just do it normally, but you just have to add the step where you change the 1 into a, because you're not allowed to get 1. Okay, you can't get 1. Okay, you can see that x has to be less than 1. So for that reason, you have to change 1 to a and say limit a approaches 1. Part B, over here, what's this? Let me see. They want you to solve this using this and this first. So let's take a look. We know that the denominator can't be equal to 0, right? It can't be equal to 0. So let's square root both sides. You're going to get that x plus 1 can't be equal to 0. So x cannot be equal to negative 1, right? So this is my restriction over here. And as you can see, negative 1 is part of both integrals. So for that reason, I'm going to change negative 1 with a. Okay? Let's start with the first one. We're going to split it into 2 parts. We're going to start with the first one. So we're going to start integral negative 2 a, because I can't have negative 1. Okay? dx over, or no, I'm not gonna waste time. I'm gonna take x plus 1 squared up fast. Okay, I don't want to write over x plus 1 squared and take it up, make it the power. خلاص. You guys are used to it now. X plus 1 to the power of negative 2 dx. Obviously, use substitution, right? U is equal to x plus 1, then du is equal to dx. So it's gonna become integral negative 2 to a u to the power of negative 2 du. Integrated, you're gonna get u to the power of negative 1 over negative 1 from negative 2 until a. Okay, change u back to its original form, x plus 1, so it's going to be x plus 1 to the power of negative 1 over negative 1. Okay, let's fix this. I don't like keeping negative power, so it's going to be negative 1 over x plus 1. Why negative 1 over x plus 1? The negative can go up, can go down, can go outside the fraction, it doesn't matter. So I just like, you know, distributing it properly. This looks cleaner, in my opinion. Okay, anyway, so what are my boundaries? Negative 2 and a. Type. We'll do the substitution later. Let's just keep this like this now, for now. Okay, and then we have the second part. It was negative 1 till 0. So we said we change a with negative 1. So a 0 and x plus 1 to the power of negative 2. We already integrated this and we got negative 1 over x plus 1. So we're going to get negative 1 over x plus 1. But this time our boundary is from a till 0. Okay, so let's work with the first one now. We want to add this to this. So let's work with the first one. We're going to say obviously limit a approaches what? Negative 1, right? Negative 1, but so what are we approaching it from? We're approaching it from the left side, right? We're starting from negative 2, we're going to negative 1. We're approaching from the left side, so we're increasing, so we say positive. Okay, so you're going to say it like this. قصدي شو positive. Since you're approaching it from the negative side, you're going from the left side, you're approaching from the negative side, you say you're approaching -1 minus. Okay, this minus doesn't change anything when you're solving. All it just shows is that you're approaching from the minus side. And you might not lose marks for it, but it's the way I was taught and it makes sense, صراحة. Because -1, you could be approaching it from the left or from the right. Since you're approaching it from the left negative side, you have to say negative. Your limit A approach -1 minus. Okay, and then write what you have. So -1 over x plus 1 from -2 till A. Now what can you do? When we say A approaches -1, that means just substitute A with -1. So you're going to get -1 over x plus 1, -2, -1. Now you can substitute. You're going to get -1 over -1 plus 1 minus open bracket -1 over -2 plus 1. Okay, obviously -1 plus 1 is 0, therefore you get over here, what do you get? Infinity, right? So infinity minus any number will get you infinity. And then infinity plus whatever you get, because remember we're solving the first part and we're adding it, the first part plus the second part. I'm not going to waste my time. In the exam, don't waste your time. Infinity plus anything else gets you infinity. So you can just put 999. But I'm going to solve it for the sake of you knowing. -1 over x plus 1 A. Let's do it. Same thing. We're going to do limit A approaches -1. But we're approaching it from 0. Okay, so like you're going to say this. You're at -1, you're going from 0, you're approaching it from the right side, so you're going to approach -1 plus this time. Okay, and you rewrite it -1 over x plus 1, -1 to 0. So you're going to say, start substituting -1. Sorry, this was A. And then you write -1. After writing the limit, you can write -1. You have to write this just to show that, oh, A, and this is A. After you show this, then you can play around with your A. -1 over x plus 1, -1, 0, substitute, get -1 over 0 plus 1, minus open bracket -1 over -1 plus 1, and as we said, this gets you infinity. So now, infinity plus infinity, it's not to infinity, so since you get infinity in your answer, that means it diverges. So when you add this infinity to this infinity, you just get infinity. Okay, so you get 999. Do you have to do all this limit and all this hebel in your exam? If it's on computer part, please don't waste your time. Okay, solve like we usually do, like I solved question 1. If it's written part, you have to, okay, unless it won't be counted as correct. Question 3, consider the improper integral from whatever. If it converges, give its value. Type, let's do it fast. 2 to positive infinity. Take x4 up, it's going to be 120 x minus 4 dx. Okay, what do? We change infinity to A, right? 120 x to the minus 4 dx. Integrate, you're going to get 120 x minus 3 over minus 3 from 2 till A, right? So you're going to get -40 over x cubed from 2 till A. Then you say limit A approaches infinity, -40 over x cubed 2 till A. So then you get -40 over x cubed. Since now infinity is A, it's going to be this. So you're going to get -40 over infinity minus open bracket -40 over 2 cubed. -40 over infinity is 0 minus -40, so it becomes plus. So 40 divided by 2 cubed is 40 divided by 8, which is just 5. So you get the answer is 5. You can do this in a calculator if you want. Question 4. Consider the improper integral 190 over x power 5 if it converges. Same thing, 2 to positive infinity. Okay, 192 x minus 5. Remember, you rewrite dx. You rewrite it in terms of A. So integral 2 till A, 192 x minus 5 dx. Again, the limit crap, you can skip all of it if you're in computer, because there's no point. But if you're unwritten, you have to use limits for both the one with infinity and the one without infinity. Okay, you need to. So if you're on computer, you don't have to do this a limit stuff. You can just keep it as infinity and use the bounds as infinity. Anyway, so integrate this, you can get to 192 x minus 4 over minus 4 from 2 till a, and this should get you 48. You should get 48 for this. 192 divided by negative 4 is negative 48 over x to the power of 4. Alright, from 2 to a, say limit a approaches infinity, right, of negative 48 x to the power 4 2 to a equals what? Now substitute negative a equals what? What's it going to be when you change a as infinity? It's going to be negative 48 over x to the power 4 from 2 till infinity. And now you actually expand it, negative 48 over infinity minus open bracket negative 48 over 2 to the power of 4. This gets you what? 0. Minus becomes plus. 48 over 2 to the power 4, which is 48 over 16, which is 3. So you get the answer is 3. Thank you so much for watching, and good luck in your exam.